So we discussed about the motion. Okay, topic is motion. We already discussed in the topic of the average speed, average velocity. Okay, now if a body is at rest position, yesterday we discussed about inertia of rest, inertia of motion, as well as inertia of direction, average velocity, average speed, and what is meant by inertia, what is meant by force. All these we discussed. And friction, how friction is acting on an object when it is moving in a straight line. Okay, all these we discussed. But we have few doubts about rest, motion, as well as average speed. Again, I will explain about average speed, average velocity, instantaneous velocity, instantaneous acceleration, instantaneous speed. All these we will discuss today. Okay, so what is meant by rest? If any object, I am writing the definition, just follow the definition as well as topic. How, if you understand the topic, it is better to analyze the topic, how it is going on. Okay, so what is meant by rest? If an object is at constant position from a certain time, okay, from a certain time, then that object is said to be at rest position. Okay, this is definition of rest. Now coming to motion. If an object is at constant moving, or you can say moving continuously, if an object is moving continuously from a certain time, then that object is said to be in motion. Okay, that object is said to be motion. Now, if any object which is moving up to certain time, from a certain time, then it have speed, velocity, acceleration, time. Okay, all these it will have. So now we are discussing about rest and motion. It is completed. So we are entering into speed, average speed, and the mathematical forms of the speed and average speed. Before that, we will discuss about, actually we discussed about the distance as well as displacement also. Today, diagrammatically, how we are representing vector format and distance displacement also we will discuss. Okay, so first that coordinate frame of reference. Okay, coordinate frame of reference. What are the conditions for coordinate frame of reference means? We have 4 types of conditions. What is there? First one is Cartesian frame of reference. Okay, Cartesian coordinate frame of reference. Cartesian coordinate frame of reference. Second one is polar coordinate frame of reference. Polar coordinate frame of reference. Third one is Third one is cylindrical coordinate system. Cylindrical coordinate system. Fourth one is spherical coordinate system. Okay. Fourth one is spherical coordinate system. All these are the four types of coordinate systems. Okay. For example, if we write Cartesian as well as polar coordinates, if we draw the examples for Cartesian coordinate systems as well as polar coordinate frame of references, in that first one is Cartesian coordinate frame of reference. Cartesian coordinate frame of reference means we will get in mathematical part as well as we will get in maths part. What is Cartesian frame of reference? This is y-axis as well as this is x-axis and this is the horizon. Okay. If any object is moving from P to Y to X, the point of combination, the line from y-axis as well as from x-axis, both are meeting at P. Okay, this is taken as y0 as well as this is taken as x0. If we write then P of x0 comma y0, this is the Cartesian coordinate system. Okay, now next one is polar coordinate frame of reference. Okay, next one is polar coordinate frame of reference. Polar coordinate frame of reference. In this polar coordinate frame of reference, we have angle. Okay, along x and y axis we have the angle. This is y axis as well as this is x axis. If we taken this straight line, the angle made by this Cartesian, which means the radiant of the surface as well as the angle between x and y axis. Okay, this is theta and this is the radius of curvature r, which means we are taking as P of r comma theta. Okay, this is horizon O. Okay, so this is polar coordinate. We will get P of r comma theta in polar coordinate system. Okay, these are the coordinate frame of references. Next one is distance displacement. We already know, but today we are discussing about distance as well as displacement. This graph, okay, which means vector form. How we are representing in vector form distance and displacement. Distance and displacement. In distance and displacement, we already know the definitions. Distance, the the path between point A and B is known as distance. Okay, displacement, the shortest path traveled by an object is known as displacement. Okay, if we take the path, then if it is point A and this is point B, if an object is traveling from this part to this part in a straight line, that is known as distance. If an object is traveling in this direction, it means path of the projectile, then this path is taken as C. So ACB is the path traveled by the displacement. Okay, if we in this manner also, if we consider this is point A, these are the directions of the distance and displacements. Okay, these are the directions of the distance and displacement. So this is the point B, A, B. So like this, it is coming in this direction and it is moving. If we combine both these two, what will happen? Diagram will be So this will be the diagram will be combined. This point is B, okay. Point A, B as well as C, okay. If we consider this one as a E and this one as F, okay, it is moving in this direction. This is the vector representation of the distance displacement, both combining distance as well as both combining display. This is distance, this is displacement. Combining these two, we will get the diagram like this. Okay, this is the distance displacement vector graphs. Okay. Next one is speed. Next one is speed. Next one is speed. Simply we can say the distance covered by an object at a certain time. Okay, in a unit time. The distance covered by an object in an unit time. Unit time is called speed. Okay, and speed equal to, as I already told you, speed equal to distance by time. Okay, distance by time. So which means we can represent V equal to S by T. V is the speed, distance is the S, and T is the time. Okay. Now, if we take average speed. So I already told you the particle or the average speed of a particle at a certain unit time is called average speed. Okay, what is the formula for average speed? V average equal to total distance by total time. Simply we can write it as S by T2 minus T1. Okay, T2 minus T1. If you want the example also, we will take it as, I already told you yesterday example. I hope you all know that. Example is, if an object is moving in a straight line from point A to B, this is point A, this is point B, the distance between them is 5 meters, then time taken is 3 seconds, and from B to C, it is C point, distance is 5 meters and time taken is 5 seconds, and from C to D, distance is 5 meters and time taken is 2 seconds. Now total distance is 15 meters and time taken is totally 10 seconds. So 10 by 15, like that if we do average. Now 15 meters by 10 seconds. Okay, so how many times? 3 as well as 2. 3 by 2, approximately we are getting 3 by 2. Like that if we done the problem, we will get. Okay, this is about average speed. Next one is instantaneous speed. Instantaneous speed. In instantaneous speed, delta S be the distance traveled in the time interval t to t plus delta t. I am writing here t to t plus delta t. Okay, so the average speed. So the average speed in this time interval is V average equal to, we can say, delta S by, which means change in distance by change in time, delta S by delta T is the answer. Okay. Next one. Average speed in different circumstances. Okay, average speed in different circumstances. Okay. Circumstances. Okay. Average speed in different circumstances. What will happen? I already told you about average speed formula. Average speed equal to total distance by total time taken. Okay. So for this, if we write the formula, then average speed equal to S1 plus S2 plus S3 by T1 plus and so on, T1 plus T2 plus T3 plus and so on is the formula. Okay. Now next one is velocity. Next one is velocity. Next one is velocity. So coming to velocity, definition is the displacement covered by an object. The displacement covered by an body or object in a unit time is called velocity. Okay, is called velocity. So velocity equal to formula displacement by time. Velocity equal to displacement by time. Okay, so this we can write it as v bar equal to velocity v bar equal to s bar by t, which means or delta r bar by t. Okay, this is about velocity. Next, acceleration. Next one is acceleration. We will conclude with acceleration. Okay. acceleration. So the change in velocity in unit time, okay, unit time is called acceleration. It's called acceleration. So acceleration equal to change in velocity by time. Change in velocity by time. Okay, this we can write as a bar equal to delta v bar. Change in velocity means delta change. Okay, we will represent change in delta. So delta v bar by t is the formula.